All right, guys. So we'll start off a little bit slow, just as people come back from their coffees or teas or whatever you're having. Um, I think we'll be another um, hour and a half. We'll try and kind of go through it, but obviously not too quick. Um, we basically got two sections left. We'll do lists, which is going to be pretty quick and just explain what lists are, and then we're going to go and build the Grasshopper one-on-one tower, which is the tower in the background, Big's Cocoa Towers. So this portion, Guillaume is going to explain with lists along with myself. So we're going to kind of free flow this one a little bit between us because lists is a really big part of Grasshopper. Before we go on, though, thank you for everyone that has commented. We are honestly blown away by how much engagement there has been on the video. We thought people would be a little bit hesitant, but it's been really amazing. Faisal's also AI. Faisal is doing an insane job replying to you guys. We will keep replying as we go. This course will be available on our website, archi-tech.network, which you can find in the link below. And we will edit the videos. It'll take us a little bit of time to edit the videos and put it on the website, but you'll be able to access it after the course. So yeah, we're gonna. And one last thing, we've already had a great response to this. You've boosted our following by about 100 or so people. But yeah, just simply like the video, subscribe to the channel. It does us a lot of help in order to continue to grow the platform. And this is also a test of our future courses. Like, maybe we'll do a live when we release the courses on our website each time we do it. But yeah, thank you for everyone that's joined. Hit that stupid little like and subscribe button. I can't believe I'm saying like and subscribe these days, but that's all we're asking for. So come on, shall we jump into this, Guillaume?
Let's do it. You want me to share my screen so I
Yeah, do
control?
you want to share? Yeah, sure. Take it
It's,
over.
it's gonna be the
It's
same.
going to look exactly the same.
All right.
So
So
yeah, lists are the key, aren't they, Guillaume?
yeah, and actually the little exercise we just did proves like the power of Grasshopper once you have to manipulate a lot of geometry at once. This is where you start not wanting to do things manually anymore. So lists are key. Lists are simply, the fact that you manipulate multiple objects or numbers or whatever at the time. Um, and so this is how it looks like if you pull a little panel, which we did to show you the difference between the kind of cable, the single line, the double line, and the dash line. But this is a list, essentially just a series of elements with a little number in front. Uh, we've showed you what it is in the script already. And in order to explain that, instead of sticking to pure geometry or numbers or things that feel maybe a little bit abstract, we brought it to a very simple day-to-day case.
Yeah, because we're thinking, how do we teach millennials, Gen Zs, and well, anyone really about lists? We thought emojis and food.
Emojis, food is international, and we can put Oliver as the first little face of the list. So that's great. That's a plus. So I guess what's important to understand, a list is just a list. Like there is not much to understand about it beyond being a series of objects or data. But when it starts to be tricky is when you start matching different lists to do things together. So this is our little list of friends, and we go to the restaurant, and each one of our friends has ordered some food. So if we put it back in the context of Grasshopper, it could be maybe our boxes as our friends, and the food would be the height of the box, for example. So we have kind of two lists, numbers and boxes that we need to match. Everything goes well if we have our friends, they'll order one thing. Oliver wants the burger, he misses the US. And the rest of the friends have their own order. So everything is clear. Now, if
I
none
see.
of Oliver's friends,
There is
no,
a joke, but a good point that comes up that in this list I would be number zero. Maybe if you go back one, Guillaume,
True.
So yeah, I am number zero, or like that person is that emoji is number zero. Um, and that is because in Grasshopper, and as far as a computer is concerned, the number zero is a number, right? So even though it ends at the number five there, that's six people in that list, not five, right? Because zero counts as a number. That's not unique to Grasshopper either. That is how computers think. Zero is a number, and that's where it starts from.
Very good point. Thanks for adding that. So we look at the case where none of Oliver's friends could make it, and he still ordered all this food. So this is kind of the classic thing where you have maybe one dimension and all of the elements you create are the same. You link a list of just one element to a list with multiple elements. This one value or this one element will be associated to all the other elements of the list. Now we have
And
the reverse. Go ahead.
yeah, this is how it works in Grasshopper. If you give it one input is one list and the other input is many, it will apply that one thing to every single thing in the other list.
Correct. And the opposite is true. If I had, say, we had this sphere, for example, with multiple points but only one radius, we created multiple sphere, but all using the same radius. So all our friends here are all together, but there is only one food item, so they'll all get a burger in that case. Now it becomes tricky if your lists have different length. Say you have all your friends, but there is more food items than your friends present in the restaurant. So by default, the behavior is that the remaining items are just going to be assigned to the last element of the first list or the shortest list. If it was reversed, if we had more friends than food, the last food item would be repeated for the last people.
And it's a good basic rule to follow is like if you have a component which has two inputs, right? If they're not a single item with multiple items, if they are multiple items with multiple items, you want to typically the best thing is that the number of items in each one is the same. So if one input has 10 things going into it, your other input wants is good to have 10 things going into it.
It's the most likely case anyways you're going to work with Grasshopper. It's very rare that you do this on purpose, that you have a list of different lengths and repeat the last. Another thing to be careful about is the order of your list. So by default, the first one would be associated by the first one. If you went to the restaurant and shuffled the whole order so that Oliver wanted sushi, he's actually going to get his taco because that's the first element that was on the list of the order. So it's really important to keep track on how things are organized constantly. And what you want to do is sorting your list so that it matches the list it's associated with.
Yeah, a lot of time is spent in Grasshopper, sometimes sorting, reordering, inserting things in list form, right? Because it's not always the case that your lists are going to be perfectly matching. Again, the sphere example is a good one, right? You want to make sure your points, 1, 2, 3 points matches with the 1, 2, 3 different size radiuses. Maybe we'll show that as an example, but
Yeah. All right. So we prepared for you guys a little file that we are sharing actually in the folder that Ollie shared.
yeah. So
Um,
if you guys go to the Google Drive that is in the comment section, sorry, in the description to this video, there's a Google Drive, and there is a Grasshopper file called lists. So if you open it up, you will see exactly this.
exactly this. And so we basically took most of the list tools, which is part of set list here and some others, just the most frequent used list tools. So we'll go through them really quickly. The goal is that you can go through by yourself and kind of see how they perform. But the
Yeah.
idea is
This.
that,
Sorry to interrupt.
yeah, the
I
idea
think
is
that
that we always,
this was a tool. Sorry, this was a tool that really helped me when I was starting, and we don't expect you to remember them all, but it's something that I kept coming back to when I began, and I was like, oh, I get what this is for. So you guys now, I've passed it on to you guys.
Yeah. So we always kind of work with a list that we created with a panel. So in order to do that yourself, you would create a panel, type in some content. I'll try to mimic A, B, C. And then you want to right click. So right now it's just actually one element. If I was to plug this, you can see it's only a cable with one wire, meaning that it takes this as just one single text. So you need to make sure to uncheck multi-line data. Then suddenly it understands the enter or the change of line as a new item in the list. So this is how you create just a little panel with, I guess in this case, just letters. But so first element or first component is the list item. So you plug in your list and you basically tell the component which one of the item you want to look at. So in this case, item number 4, E. See how it's not the fourth item, it's the fifth. It's basically the one with the index 4 in front of it. So always keep in mind there is a 0. So if you want your fourth item, you may be looking at the one with index 3. This is basically the index of the actual item in the list. Now we can also reverse a list. So pretty straightforward, going from bottom I, H, G, etc. So this is reordering in a sense. Insert list. So you input your list here and a second list that's right there. And then you tell at which location you want this list to be inserted. You see here I inserted that index 5. So I have my little hashtag, 2 hashtag, 3 hashtag showing up at item 5 here. And if I manipulate this, you can see how it shifts around. Keep in mind that insert actually replaces the elements. Sorry, it inserts, so it makes the list longer than it was. So we had 8 here plus 3, that's 11. There is another tool that actually replaces, that's why I was confused, and actually changes the order, but I'm not sure we have it in there. It's not as useful. List length, it's just basically measuring the length of your list. So here I have item number 9, meaning that I have 10 elements in my list. This is what my output is.
This seems like kind of a useless component, but actually this is really useful because let's say you subdivide your surface of your facade into panels, and you want to know how many panels there are. You can measure the list of your length, and you realize you have 320 panels or whatever it is on your building.
Yeah, this is something also you can get. I'm just gonna pull a little thing where you just fly over close to the output. You can see it says 10 values. So that's a quick way also to get the length if you don't want
Actually,
to.
we missed that, didn't we? If you want to sneak peek inside the information and like this panel, yeah, like Guillaume's doing, hover over the input and it creates a window of what's kind of inside it, and also a little summary at the top, like 10 10 items.
All right, partition this is one that actually starts to bring the tree structure in, but what it's doing, it's taking one list and splitting it into a series of lists, creating an actual tree. We'll cover that in our Grasshopper 102 tomorrow morning. But I mean, pretty self-explanatory at this point, just creating groups of 2 elements or lists of length 2 out of the longer list. Here is my replace. I knew it was somewhere. So in that case, you can see that it was almost like insert, but I keep the list length the same, and I replaced, in that case, F, G, and H by what's contained in that list. And I can move this around. Shift list, that's a quite interesting one, actually. You may use it more than you think. You're basically shifting the position of the elements. So you can see that A is here at position 0. It actually came back at 8. So a better one to look at is E, position 4, because you shifted by 2, this number here as an input, E became number 2, so reduced by 2 in the index. The reason why A went from the start to the end is that there is this rep input here that allows to basically, as you shift things around, the first go back to the end and you keep the same amount and you don't lose any item. If you switch this input to a false, so say that you do not want to wrap your list, you can see that the A and B disappeared in that case and they were not put back at the back. So if I keep shifting, it slowly disappears, all of them. Sort list, super useful one. That's the one I use every single time in every script, I think. It's a little bit tricky at first, but you'll get used to it. It has 2 inputs, K and A. K are the actual numbers that are gonna be sorted. So in that case, I have this list, 174, etc. A list of numbers that is disorganized. And you can see that it sorts it and put them back in order, 1, 2, 3.
This one definitely took me some time to understand, but it is also super useful.
Yeah. So the reason why you have the A is that you're able to sort other things at the same time you're sorting these numbers. So say you want to sort objects based on their height. For example, you would plug in their height here and the actual objects here. It would sort the height, so you would get the heights in the right order, but you would also get the objects at the end of the day sorted with their height. So here, for example, A corresponds to the number 1, so it was not moved. But for example, E here was at place 2, corresponds to 7. 7 came as item number 6, and you can see that E is now at item number 6. So it was moved the same way these numbers were reorganized. Play with it, you'll get it, and it's extremely helpful. Split list, pretty easy. You have a long list, you cut it in half, and you have 2 pieces coming out, A and B. A, what's before the index you want to split at, and B being the second part of the list. Subset, you use a domain, so it's kind of splitting, but just taking just a piece of it and saying I want to start from 3 all the way to 8, for example, and you get just a subset of that list. We have a few more. Dispatch with a pattern. So this is, for example, by default, you can see a true-false pattern. So that means that it's going to take the first one, true. So yes, it takes it. That comes out of the A. Second one, false. It actually doesn't come out of A. It will come out of B because it corresponds to a false statement. And then because I only have 2 true and false here, it's going to repeat again true. So my number 3 corresponds to a true, come out here. 4 would be false, comes out here, etc. So you could do a pattern yourself instead of having this true false by default. And maybe I do true, true, no spelling mistake allowed, false, and true again.
Yeah,
So a different
unfortunately,
pattern.
Grasshopper doesn't do spelling mistakes that well. Right? It's difficult when you're dyslexic like me.
So you can see that now the pattern has changed. So my output have changed. I go true, true. So I actually go 1 and 2. These are going to come into my output here. Then third item is false. Takes 3, puts it out in this list. And then I go back to true again. So the 4 comes out in the, basically take A as the true and B as the false output.
So again, like to architecturalize this, let's stay on the facade example. Let's say you have a weird facade where some of the panels are rectangular and some of them are trimmed at different ways. You could measure how many corners the panel has, right? If it has 4 corners, you can assume maybe it's a rectangle. If it has 5 or 6 or 3, you know that it's a triangle or it's had like the edge trimmed off, right? So you may want to, in your script, send all the rectangle panels to another portion of your script and all the triangles to another portion. if they're like 3 points, right? So a lot of this, like we understand that this will look like why would I use this and kind of stuff. And we're not expecting you to remember it. This is something for you guys to come back. We're kind of planting the seed in there. So later on, you're like, oh, actually, I do think I know where this is coming from.
Pick and choose, very similar, but actually acting a little bit differently. You still have a pattern, true, false here. And what it's doing is it takes either from this list here or this list here, the same way the dispatch list worked, but it only outputs one list. And what it does is that I go true, meaning that I'm going to take one corresponds to true in the binary language. So it's going to take first the item from the true list here, one, puts it as an output. Look at the next one, false. So it's going to take the input from the 0 or false input list. And in this case, takes the second element. And then next is going to be true. So it takes the 3 here, put it in, and etc. Weave looks exactly the same, and it's confusing at first, but it does something slightly different. See how here I have 4 true false, and it basically went through and took for the first item of this list, second item of this list. In Weave, it's going true, take the take the 1 because it's the input from the true here, take the 1, put it in, and then the second item, it's actually going to take the first item of this list. So it's basically slowly going through the list, but never skipping any. So if I go true, false, it goes 1, A, 2, B, etc. Where the other one was going 1, B, 3, D, if that makes sense. It kind of like keeps the index as the reference of which element to take in each list instead of taking the first one available that was not used yet. Hope maybe
Weave
you
is
have a different way of explaining it.
Yeah, no, Weave is a bit better when the list is grafted, which we'll
Yeah.
explain a little bit more tomorrow. But yeah, that's the best one.
And longest list quickly kind of solves the issue when you have lists of different sizes. You can input a bunch of lists and you can actually add more. If you zoom in, you have access to this little plus minus. This actually happens in a lot of components. So if you want more input, think about zooming in. Some will allow you to do that. But longest list is going to look at the different lists you input, look at which one is the longest, and then it's going to multiply whatever it needs to in order to have the same amount of items in all your lists. And it's going to do so by repeating the last one. If I do this, for example, you can see that I have 2 here, I have 9 here. It had to repeat the last one a certain amount of time in order to get 9. And if I had something else here, small, and you can see that the last one has been repeated. All right, that's it. So again, as Oliver said, don't need to remember all of this. Just know it exists. If you have some stuff to do with list and you're not sure, go back to it and see if something corresponds.
Guillaume, should we do maybe make the list of names and food and just concatenate them to show how it works?
We can concatenate, yeah.
If we let's just make it super quick. So like if we recreate the diagram we were talking about, just we're just going to create 3 or 4 names. I think 3 is fine. And then we're going to create like a list of food as well. So I don't know, what can we do? Burger, croissant,
Fresh
of
after
course, for
all.
Faisal.
Don't know what
And then
Faisal wants. Is he a sushi guy?
sushi, yeah, go on. So this is basically a recreation of the diagram, right? We have a list of friends and we have a list of food. There's a very simple component in Grasshopper called concatenate, which is coding words for join text, essentially. So you can concatenate, join two pieces of text together, and you can create a separator by right-clicking on it. And if Guillaume puts like eats or something, there you go. Space eats. If you see what comes out the back of it is the result of. So Ollie eats burgers, Guillaume eats croissant, and Faisal eats sushi, right? So this is when the list matches perfectly. So everyone's happy. They're eating the food that they wanted and ordered, right? If we do like I get the first item from the first, yeah, or reverse. Like if we reverse that list, right? Um, the components obviously will still work. So now the list is reversed. But now I'm eating sushi and Faisal's eating burgers. Guillaume's happy he's still eating his croissant because it's
Yeah, that
doesn't
is
affect him.
it's hard coded in Grasshopper. I will always eat the
Yeah,
croissant.
but like if you get just one item from the list, Faisal, like sorry, Guillaume, I'm reading the text whilst I'm talking to you. Like if you just do you want to do list item?
Yeah.
Just grab the first. So in this example, like he's just going to grab one item from the list, right? And so you'll see that the wire that comes out of this is a single solid wire. And so there's just a burger being inputted. And therefore, everyone is now eating burgers. You
Even
know,
me can believe
even you, yeah, which is not a bad thing. Um,
it.
yeah. So yeah, this is a little bit of just to show you guys how the diagram works in the real world of Grasshopper, so to speak. I think we'll leave it there for lists because we understand that you guys this may be a little bit alien of what these like. Why would you want to do all these things? We're going to cover it in the next part. But I think we just want to plant a seed, and we obviously given you guys the file. This was something that really helped me. Afterwards, as I was creating scripts, I know I want to insert some things in here, but I've forgotten what it is, and I went back to this file a few times. But so that's the little introduction to lists. We wanted to keep it, simple and hopefully understandable, but give you guys a bit of a seed to go back and understand a little bit later. Which brings us to the final part of this course. So hopefully, I think we'll finish in about 45 minutes and we'll do some questions and that kind of stuff. If anyone has any questions for lists now, then jump up. Otherwise, we'll get started with the next part, which is our building scripts, which I'll kick us off and start the scripting, and we'll script the massing. And then Guillaume will take over to finish and script the actual building elements of facade and floor plates and stuff like that. So we got one question, and maybe I'll bring up. If you want to make a facade panel on a pattern with different shapes orders when using list, how do I make fast by not typing true or false? Any suggestion which using list of commands? Yes. If you tune in tomorrow, we'll answer this question through data trees. But you can use the what am I saying? Like you can create a pattern like through the repeat lists. What else am I thinking, Guillaume? Like a true or false statement based on something. So, but tomorrow we'll show you. We're actually going to be creating a facade pattern using data trees to create like a checker pattern and things like that. So, if you guys tune in tomorrow, you'll find out exactly how to do that.
Yeah, and you can generate your true or false. Basically, a true or false is a Boolean result, and it could be the result of like checking if something is bigger than a number, and then it gives you a true or a false response to that, and then you use this in order to uh, create your pattern, for example, or is this panel above 30-meter in elevation, true or false? And then that's going to trigger maybe there is a pattern starting at 30 meter of elevation.
Someone's asking, will we explain domains? Yes, we will. A little bit later. I mean, domains we kind of touched on. I don't know if you were there earlier, where Guillaume was showing us the domains of the boxes. We will cover domains a little bit in as we're building the Cocoa Towers. Uh, oh, can you quickly explain how to use Grasshopper to categorize these boxes into similar sizes categories as you did for the Serpentine? Um, Maybe we'll come back to this. I don't want to go back and explain that, but essentially, um, yeah, we could use domains to create to measure. Well, I guess with lists, what you could do. This may not be a great way, but like uh, you could sort all the sizes of the boxes in a list and then partition them into 5, 6, 7, 8, 9, 10. And what you get is you get groups. They may not be like super similar size, but it would be a very quick and simple way to optimize them. Um, Maybe we'll have to follow that up with a little video on
Yeah, you,
Discord or something.
you can do what we kind of explained, where you test. You know how you had the height as a number. You can do a kind of a if statement. Basically, check if this number is maybe within a domain or bigger than a certain amount, and then you use this true or false to create kind of a sublist that you would apply a color, say for example,
Yeah.
or you kind of put it on the side.
Someone's asking us about voxelization, which is just a term to pixelize things, I guess. Is voxelation hard? Yes and no. You know, sometimes it can be a bit more complicated than you might think. The box example, the sculpture, is a good example of one way to create a voxelization style, right? We often use surfaces, project a grid onto the surface, and that's how you get like a wavy pattern. Think of, you know, the Vancouver Tower. I think that was actually created by projecting the a grid of boxes onto the surface, but just in vertical form instead of horizontal like we did.
Yeah. Another
Um,
thing you could do for voxelation, imagine a giant box that's split into a lot of tiny boxes, and then you have a geometry going through it, and you try to detect which one are intersecting, or
yeah,
like which box is intersecting that surface, and just keep these. That could be kind of a type of voxelation too.
yeah. A lot of the stuff, it can be a mix of true voxelation is like you fill a mass with voxels, but there's often like pseudo voxelization, a bit like the sculpture example where it kind of, you know, is extruded boxes. Is there a balance between what you do in Rhino and what you do in Grasshopper? Is there a principle to follow to know this? So yeah, there is a bit of a balance. I don't know if there's not a hard principle I can give to you. It comes just with your own knowledge and experience of Grasshopper. So one thing I would say as a principle is like even at a very advanced level, I'm very rarely, you know, I'll get close to 100%, but um, sometimes with scripts, you can get very quickly to 90%, like you're doing 90% of what you want to do. That last 10 or 5%, um, can take a significant amount of time for you to solve that one thing. And sometimes your script gets you really close, and then you bake it and make some little manual adjustments. And it can be a nice way to add your designer flair, like literally your physical touch onto something. Um, I think you're always balancing, is this going to how much time is this going to take to model manually versus how much time is this going to take to model computationally, and the pros and cons of doing it either way. I think this next challenge that we're going to do is going to illustrate exactly that, because we're going to model it manually, the mass manually, and we're also going to do it computationally.
And keep
Uh,
in mind, like some designs are very rational and rule based, but
yeah,
there is always like, if you want your design to be a little bit manual and free floating, like you can't define this by proper rules. necessarily. So that's where you want to go more in the manual side, and maybe you just use Grasshopper to create panels after you generated your whole building manually. You know, just there is an art, and like, am I going to take more time figuring this out? And the rules are really complex, and everything takes forever. But I'm just going to do it one shot. So maybe in that case, I'll do it manually.
Yeah. Maybe we'll take this as the last question. How do you write custom text results eats below a component? So that was specific to the concatenate component, right? That specific component has an input. So like it's joining a text together, but you can choose what goes in between that text. So if you right click on that component, it says separator, and you type in what that thing is. That is unique to the concatenate component. That's not something you can add to every single component.
Yeah, some components have kind of hidden options that show in the black banner underneath. It's very case to case.
All right, so I think we'll pause the questions here.